Hi, my dear students. This is Dr. Syed from DBS Institute of Technology. Today, today we are going to discuss about surface texture. This is unit number 3, metrology, surface texture. Surface texture is a part of mechanical measurement and metrology. The characteristic quality of an actual surface due to small departure from its general geometrical form, a pattern or a texture on the surface. The surface texture, it is the characteristic quality of an actual surface due to small departure from its general geometrical form of a pattern or texture on the surface. What is a surface texture? Say it is the actual surface because of the small departure from its general geometrical form. You will see some other pattern of the surface texture. The problem is basically geometrical. So what you are seeing is, you will see the geometrical problems. These problems are classified as follows. First order, due to inaccuracy of machine tool. Say, before going to this, you need to understand what is a real surface texture. See, whatever the surface we see, if we see the surface is having a mirror finish, what we say? We can say that it's an excellent surface texture. Suppose if we some lines on the surface, we say that the surface have some scratch lines. If the surface is uneven, then we say that this is an uneven surface. Like that, different names are there because when the surface is not really quite well and good, we will call the surface in different names. One, first order, due to inaccuracy of the machine tool. How a bad surface will occur? The bad surface will occur because you are not using an accurate machine tool. Inaccuracy of the machine tool. Second one is due to vibration of any kind. See, when the machine is running, if there is any vibration in the machine, your surface texture will be spoiled. Third one is due to characteristics property of machine. The third one is the characteristic properties of the machine. Machine characteristics. What is the machine characteristics again? See, a plane surface can be done with different machines. We can use a milling machine. We can use a shaping machine. Or we can use any planing machine. Or we can use any grinding machine. So, It is the property of the machine, though if you work with any machine with high skills, but the surface what you get may be according to the property of the machine. The fourth one is the rupture of material. See, if your material has been ruptured, then again you won't get proper surface. Now we will see the surface finish terminology. You can see the surface finish terminology. See, the surface have different names, it have different terminologies. One, the surface may be rough. Two, the surface may be wave, where we have waviness. And again, the surface may be excellent surface, very good surface, without any defects. Then you will have fourth one, actual surface, then nominal surface, then roughness height, roughness width, cutoff, waviness height, waviness, waviness height, then profile of the surface, then center line, then effective profile. So if we see the diagram, we can see this surface is a longitudinal surface. This is a longitudinal type surface, where on the surface we will have some flaws, and some places you can see some waviness, and some places have roughness. Like this, it's a combination of different types of defects. So, there is a defect on the surface. Then, how we are going to measure the defect of this surface, or how we are going to measure the finish of the surface? Number one, surface inspection by comparison method. We can measure it with the comparison methods. You can see the surface inspection. Number two, direct instrument measurements. Take an instrument and measure it directly. Number three, other methods of measuring surface finish. We have different methods to measure the surface finish. Number one, touch inspection. In this method, fingertip is moved at a speed of 25 millimeter per second, and irregularities upon 0.01 millimeter can be measured. See, this is a manual method where we can use our finger. Your finger is moved at a speed of 25 millimeter per second. Again, we can sense the irregularities up to 0.01 millimeter. This can be measured. This is one method. Another method is visual inspection. What does it mean? What's a visual inspection? It means visualizing by naked eyes and is just a subjective evaluation. See, somebody will ask you that he will show something and says, just see it how a good finish it is. And you will take that object, you will see it, you will touch with your hand, but by seeing your eyes itself, you will say, oh, very nice finish, excellent finish. This is a visual inspection. Then another method is scratch inspection. Scratch inspection is a lead or babbitt or plastic is moved along the surface to be inspected. Scratch inspection is a babbitt or plastic is moved along the surface inspection. Along the surface to be inspected. This is my scratch inspection. Microscopic inspection. Microscope can only measure small surfaces compared with the master surface. Number 5, surface photograph. So in this microscopic inspection, microscope can only measure small surfaces and it is compared with the master surface. Number 5, surface photograph. Take the photograph of a surface. A magnified photograph with the different illuminations are taken. So, we'll have to take magnified photographs with different illuminations. Number 6, micro interferometer. What's this? In this method, an optical phase is placed on the surface to be inspected and illuminated by a monochromatic light, and then interference band are studied by microscope. Number 7, Vales Dynamometer. It consists of a pendulum which is lifted to initial position and allowed to swing over the testing surface. Surface smoothness is determined by friction as swing time is a direct measure of surface finish. So it consists of a pendulum which is lifted to initially position and allowed to swing over testing surfaces. Surface smoothness is determined by friction as the swing time is direct measure of the surface finish. So here what happens, a pendulum will be moving from left to right over the surface. If the surface is more rough, it will take a long time to move from one side to the another. Or if the surface is smooth, then you can take, then if the surface is very smooth, the pendulum will take very little time to move from one side to the other. So this will tell us the surface roughness. Number 8, reflected light intensity. In this method, a beam of light in this method, a beam of light is projected upon surface and is reflected in several directions as beam of lesser intensity and change in length in different directions is measured by photocell. Then you can see here a direct instrument measuring method. One is Profilometer. This is commonly used in USA for direct measurement of surface quality. This instrument is best suited for measuring surface finish of deep bores. You can see the right side. This is the Profilometer. So profilometer, this is a diagram of a profilometer. Here you can see a stylus or a probe. It is set up over a surface. It is set up over surface. This stylus consists of a spring. The spring always try to move it down so that it should be always in touch over the surface. See, by moving this, we can find out the surface is how much is rough or how much is smooth. This instrument is best suited for measuring surface finish of deep bores. Suppose if a bore is there, that is cylinder and bore. You want to see the finish of the bore. We can use this profilometer. Number 2, Tomlinson surface tester. This is designed by Dr. Tomlinson. It is reliable and cheaper. It's also it's a slow in operation, but not suitable for continuous use. It's very delicate and requires more care. Direct instrument measuring method. Direct instrument measuring method. See, here is a diagram. We can see here a vertical shaft is here. At the bottom, there is a diamond probe, a diamond probe. And at the bottom, a surface, an object is kept which is having some rough surface. Over this, an angular skid has been kept. And above this diamond probe is in contact, is in contact. So what happens here, you can see here at the top, there is a spring. It is attached to a vertical bar, and the spring tries to move the bar towards the right side. So here you can see at the center there is some body is there. Over the body, an arm is there. This arm consists of a pointer at the end. Now, how it works? See, when you kept this diamond probe over the skid, and the spring tries to pull it to the right side, the skid will just move over, skid will just tilt over the job. This job, when the job is having some rough surfaces, the diamond probe will have it will have some type of vibration because of the rough surface. Because of the rough surface, when this diamond probe moves over the surface of the skid with some vibrations, the arm where at the end a pointer is there, and you can see this may make a graph of how much vibrations it's taking. So because of this vibration we will get a graph, and it shows the impact of the rough surface. So you can measure this rough surface here. The Taylor-Hobson telescope. The telescope is an electronic instrument working on carrier modulating principle. Microprocessors have made available complete statistical multi-trace system measuring several places over a given area and can provide standard deviation and average over area type reading and define complete surface characterization. So the Taylor-Hobson Thales surface is an electrical instrument. It's a work on carrier modulating principle. Microprocessors have made available complete statistical multi-trace system measuring several places over a given area and can provide standard deviations and average over area type readings and define complete surface characteristics. You can see here, this is another instrument, direct instrument measuring method. You can see there is one skid is there, a body, and a armature winding is here. Armature winding is here, and this consists of an oscillator, one amplifier, another demodulator, and so many things are here. This is another type of direct instrument measuring method. You can see here, this is a lead screw. This is a lead screw. Or this one nut is there. And the lead screw is rotated. At the right side end, there will be bevel gears. And its rotation has been converted to the horizontal rotation, converted to vertical rotation. And you can see here at the left side, there is one stand is here. And there is one oscillating mirror over the stand. And at the bottom, there is a stylus or tracer point. And you are keeping a surface here which is having some roughness. Having some roughness. So what happens here? We have taken a lead screw, and over the lead screw there is a nut is there, and over the nut we have fixed a job which is to be tested. Because of this, because of the rotation of the lead screw, the nut over this lead screw it moves. When it moves, the job also moves. When the job moves, the stylus that is over this job, one pointer is there. This pointer will move, but because of the roughness, it will vibrate up and down. It will vibrate up and down. And you can see here, there is another reflected mirror which has been kept at vertical. And we can you can see at the right side that is light source, then one lens is here, then there is a precision slit. So when the light source passes from here and it comes over the mirror or the job, again this is reflected and to the right side, and then at the end there is a uh, there is a revolving mirror. So what happens when the job moves, the stylus moves. When the stylus moves, and have vibration. These vibrations can be seen through the light source, and the light source reflection is taken to the revolving mirror here. By this, we can measure the roughness of the job. We can see that the details that is light cross section method. In this light cross section method, we have kept a surface here and at the right side there is a light source. After that, then condenser is there, then precisional slit is there. From the slit, the ray passes through and touches to the surface of the job, which you'll have to test it. Other methods for measuring surface roughness: 1. Pneumatic method, also known as air leakage method. Pneumatic comparator is used. Air discharge is measured by a special variable air flow meter. You can see the instrument here. Here there is a float, scale is there and tube is there. This is a pneumatic method, also known as air leak method. So pneumatic comparator is used. Air discharge is measured by a special variable air flow meter. Number 2, light interference microscope. You can see the diagram at the right side. It is a non-contact process. It is directly related to RA value. Good resolution can give scratch spacing of 0.5 micrometers. Methylene Instrument. The instrument assesses the surface through its frictional property and the average slope of the irregularities. RA value ranges from 3 to 5 micrometers. Methylene Instrument. This instrument assesses the surface through its frictional property and the average slope of the irregularities. You can see here. This is an operating trigger. When you press the operating trigger, the instrument is moved over the job and we will be able to find out how much roughness it will have. The value of the RA will range from 3 to 5 micrometers. Adverse effect of poor surface finish. 1. Fatigue strength. High surface finish increase fatigue strength. Number 2. Wear resistance decreases with poor surface finish. Number 3. Corrosion, corrosion resistance decreases with poor resistance. So one is fatigue strength. High surface finish increase fatigue strength. Number two, wear resistance. Wear resistance it decreases with poor surface finish. Corrosion resistance decrease with poor surface finish. So these are the disadvantages of fatigue strength, wear resistance, corrosion resistance. So this is the end of this topic. Surface finishes, how to measure the surface finishes. My dear students, hope you understood well. If you doesn't understand, please contact me. I can explain you well. Thank you very much.